were text pad. There it is, week 3, and inside week 3, we have to call it what you call your class.java. Right, so I called it student information. I couldn't think of a better name. Okay, so we've learned a new type today, byte. Let's see what is the maximum value we can put in that byte. And to prove to you that it can't range more than -128 to 127 if it is unsigned. So you can try with unsigned first if you like. And then we can go to sign, right? So let's see. Can I give a value less than 128 in it and more than 127? And if I try to do that, it should blow up, right? It's a runtime error. That's its limit, -128 to 127. So I'll show you it won't work. I ask the user's name, which I use next line, and then I say, what is your age? And then I say, hello, whatever, welcome to CS department, you are this much old. The rest remains the same. Let's see if it works. Okay, so please open up your command line and see where you have saved it. That's your first job, to go to see where did you save it. So wherever you are saving it, please don't put it on desktops. Please don't put it on where you don't know. And then you don't ask me. Please see that your work is organized. It will help you in the long run, believe me. So let's open a command line window, our best friend for a couple of weeks. Let's change the directory to where you've saved your program. That is where I have saved my program. Let's give it a compilation command. And it was called student something, tab. And let's compile it. And we don't have any errors. So I'm repeating this for you again. You should know how to compile and run your code on the command line, and it carries marks in your assignment. If you cannot do it, you will lose 2 marks. And how will I test it? Any day, right? I'll just come around and say, can you compile and run it for you? Maybe today, whenever I get time. So see it works. And if it doesn't work, ask me how to make it work. Or we have Greg Smith just down this corridor. If you go down, whatever, the room that you hit as soon as you go down the slope. Greg Smith at georgiancollege.ca. If you have any problems with software, go to him. If I'm not around, okay? And he'll help you. But if you're still stuck in week 4, you need to see me. You're doing something wrong. Okay, so the program compiles. I don't know whether it's right or wrong. I have no clue. So let's run it. So for running, we have Java, and we again go S, and there is no other name. That's the best part. If I try to give them unique names, then at least, then at least I can use the tab key. You don't say .class, you just say Java student information. So the first question that will be asked of me, hopefully, if things are okay, is what's your name? I'm going to say my name is Anju. I can put blanks in it. Anything, you can put anything till you enter your enter key. Press the enter key. It says, what's your age, Anju Chawla? Notice how it has put my name there. I have my name. I can show it to the user now. And that's becoming more personal now. Makes more sense. Now you know how to do printf, right? Now my age is 50, and I do an enter, and it says, hello, Anju Chawla. Welcome to the CS department. You are 50 years old. Looks good. Works well. Let's try it again. Okay, let's try 150 as my age. I'm out of range. Byte only takes 127, maximum positive value. Whoops, it says, something is wrong. You said you will use a byte. You're out of range. You can give 150. That proves to you I cannot go beyond 128. Try 129. Let's try it again. Let's try to give a negative value. Nobody lives negative, but you asked for an input, bless you. I'm -11 years old. And I took the value because I didn't say it was unsigned. Odd, incorrect, illogical, right? So the program runs, but it's not logically correct. Let's try to give a value out of the range, which is -127. I'll give you, which is -128. I'll give a -120, -130. Oops, again, the same problem. So do you see the use of using the right box? It has a certain range. You cannot give a value more than its maximum. You cannot give a value less than its maximum. But you can give both positive and negative values. You never said I can give negative values. You'll say, oh, you know what? I can do a check. If the user says I'm negative years old, I'm going to tell him, don't fool me. Yeah, we will learn all that. We will learn all that. We don't want somebody to give an age of a negative number. But to make it without any extra work, let's try to do this. Let's try to do this. So we'll do one job at a time. We'll make it unsigned. So bear with me if I have a runtime error. That's what happens when you write so many and learn so many languages and teach so many languages. You don't remember the syntax. You remember the way it has to be done, but you don't know whether the unsigned has to be written before or after. So I've changed something. I've changed it to unsigned byte. Fingers crossed, no clue. Let's go back. Remember to save it. Anytime you make change to your code, you have to compile it again. Okay, you have to. So I made a change. I don't know, let's see. It says you have 2 errors. Okay, so it doesn't like it. So let's try the other way around. And God forbid, is there a way not to do it in Java? I'll cry my heart out. I really will. By default, it is signed. Now we know that. By default, it is signed. I still have 2 errors. Okay, so now what? Now what? Google is my best friend. Again, I have to go back to Google. How do you declare a... God's sake. Give me a declaration. That's all I'm looking for. By default, in type is how to use unsigned integer in Java 8 and 9. Declaring an unsigned. How tough is it? Java has no unsigned integers there. That's really bad. Java does not have any unsigned integers is what it is saying. So it says it will allow you to use the int type to perform unsigned arithmetic. So we'll have to do it ourselves. I can't believe this. No, I don't believe this. I'm not going to Stack Flow. Let's try a different site. Maybe I'm wrong, but it's really so. If there is a Java 8 unsigned integer, Stack Overflow, I don't ever go to. People are asking and answering, but who knows, right? There are blogs of Oracle. Ah, they're telling you to use classes. To avoid dealing with overhead of boxed values, unsigned does not introduce new tab. Okay, guys, it doesn't. Okay, there is an annotation type, it says. Let's try that. I don't know if it will work, but join the discussion. It would be nice. So I'll go back and I'll get an answer for you, for sure. But from what I look, I can't do it so simply as I would have done in any other language. But I'll try this for one last time. What are these annotations? Annotations, very quickly, you've been introduced to annotations. They're kind of information that you're giving to the compiler. So let me try if it works. I could be wrong again. So see, that's how you learn. I never even thought about it. Like I thought, oh, what's the big deal? Okay, I'm still getting a big deal. Okay. Won't waste your time. We'll come back to it. I will figure it out. Yes?
Can you try typing unsigned and byte without a space in between?
Oh, you mean like one word?
Yeah.
Okay. Okay. So Brett has come up with something. Let's try it. Hasn't turned blue, but who knows?
Capital B as well.
Oh, capital B as well. Okay. But then it becomes a class.
Oh, okay.
That's what I was saying. It's available in classes. Right? I don't want to go to classes yet. There is a class. So that's what it will become. So for now, I'm only talking about basic data types, okay? And that's why I didn't want to go. I read that. Remember I said, oh, it's available in classes. For now, we'll leave it like this. I'll come back and I'll figure out and let you know. I'll tell you an easy way, and if there is no easy way, then we'll have to jump to classes. Okay, so the program works. So what's wrong? Why is she telling us to do a thing a certain way? I'm going to show you something. I'm going to ask the age first for whatever reason. So I'm going to comment this out here, okay? I'm going to take it here, and of course if I take it there, I can't put the name, person's name, because I haven't even asked the person's name yet. So my job one, I'm going to ask for the age first. Okay, doesn't seem anything wrong in it. You ask the age and then you ask the name. Is it necessary to go in a certain order? No, right? It is not necessary, but let's see what happens in this case. So I've asked for the age first, and then I've asked for the name. So I'm using next byte first, and I'm using next line afterwards. Let's save this and run it and compile it. There, it is compiled. Now let's run it. It says, please input your age. It never even asked me for my name. The question came, what's your name? But it didn't even stop for input. That's strange. Like, logically, there is nothing wrong in it. I said, what's your age? I gave in my age. To finish it off, I had to press the enter key. And then the question came on the screen, but it didn't even let me give my name. It just went to the display. That's the reason I told you to read the program name first, then the student ID, which actually should have been a string. IDs are. Let me explain the reason here. My explanation here is valid for Java, maybe valid in other languages also, not maybe, is valid in other languages also. Think about it a little, okay? And ask me questions. But this is something that you should know, again, because in the long run, you're going to work with input. Okay, this is what happens. When you ask the age of the person, the 55 with the enter key, I'll call it enter here, okay, has gone into an input buffer in the memory. When you give input from on your keyboard, it goes into an input buffer. And from the input buffer, it is kind of transferred to your age, for example, the variable age. So what did it do? You said next byte. So it read it, and it took that 55 and absorbed it into the variable age. When I say absorbed it, it's no longer in your input buffer. It's gone from the input buffer and it went into the memory variable. Now, your input buffer has the enter key still sitting there. And there is where your pointer is. So the input buffer is not empty yet. You haven't flushed it. So some languages will give you a method to flush it. Clean it, please. Any extra input, right? So it's sitting there. So when the question comes, what's your name? It has the new line in its input buffer. And it says, oh, enter key, done. That's your name, nothing. So the extra input that you did after the next byte, next int, next float, that you press the enter key, is still sitting in the input buffer, has not been absorbed. It is still sitting there. And so when you ask the question, what is your name, which is expecting you to press the enter key when your work is done, next line, it absorbs that enter key and says, oh, the work is done. It doesn't even ask you. Make sense? So now what do you do? One, you could flush the input buffer. So if there is a method that allows me to flush it, for example, C has a flush method, C# has a flush method. I'll tell you another way where if you can't find flush method in a language, what do? What do you want to do? You want to take this enter in the input buffer and absorb it. Like just throw it, let's say, throw it away. What do you think I can throw it away with? You've heard of an empty system out println to put extra spaces. What if I do this now? Let me just ignore. So after this next byte, to flush or to ignore the extra input in the input buffer. So by default, that line is not absorbed. In next line, it is absorbed. So therefore it asked you for your age when age was asked afterwards. But here it still sits. So to ignore the extra input in the input buffer, you could simply do this. This is one way. Call your scanner again and just go next line. And just empty. Don't save it any, oops. Don't save it anywhere. Don't do anything with it. It's garbage. You're trying to say ignore it. What will happen? The enter, the next line says I'll read everything till enter. It will take that from the input buffer and it will throw it away because you didn't assign it to anyone. You don't have to assign it to anyone. You'll say, what if there was more? Then of course, flushing would be better. So try to research on how to flush the input buffer in Java. That's your job. I've given you an easy way. Now see how it will work. So what have I done with this statement? It's a statement that is taking input from the user, is not saving it anywhere, and it won't even ask for anything actually. It will just take that extra enter in your input buffer and it will eat it up. And that's what you want. The buffer is now empty, so it will ask your age now. Right? Sorry, now it will ask your name. So let's try it now. So this is one way of doing it, not the best way because it's only eating till the end of the line. But if you had something extra or so on, you'll say, oh, what if I had numbers I want to ignore or something, whatever. Then of course, if there is a way, you can flush it. This will ignore everything till enter. Everything is kind of eaten up, right? So let's try this now. Let's go back. I've made a change to my code. So I'll have to compile it again. It's going to ask my age first, which I will give. And here is the question. Please input your name. And there is my answer. So reading an int or a float or all of any next, if you read something from the user will definitely give the value and press the enter. As soon as the user presses the enter key, whatever you've read, including the enter key, goes into an input buffer. From the input buffer, whatever is required goes into the memory box. So you said next byte, it picks up the 55, it knows, oh, that's the byte. It picks it up and puts it in age. But it still has the new line character sitting in the input buffer. So it says, now what? So the next question, if you ask, if it was not a next line, when you were using a next int or something, it would have been a different story. But you said, now I'm going to say next line, read till next line. It already has a next line in the buffer. It says, I've read it. So it didn't even ask you. Does it make sense? So there is an input buffer in all languages. Everywhere you have to be careful of this input buffer. So what did I do? I said, I'll take care of you. I'll flush you out. And again, as I said, some languages have a flush method. You go ahead and see if Java has a flush method. Go and Google it and see, like I did and didn't get a result. But anyway, when I tried my unsigned, so you see if you can do that. But I've given you a solution. And that solution is, I said, oh, I'm going to read till the end of the line. And I'm trying to read to the end of the line. No question appears on the screen because I don't want to put a question. That's what that's what the whole confusion was. The question came, what's your name? And it didn't ask for an answer. So I've kind of taken that extra input in the input buffer and I've flushed it. So I took it dot next line. I use the method next line because I want to flush till the end of the line. It took whatever was extra would have been, whatever it was. It just flushes everything in the input buffer. Now, when the input buffer is empty and you ask a question, it says, oh, the input buffer is empty. Let me ask the user for an input. Make sense? That's the reason I told you to read the program name first, which was a string, and then go to int and then go to float. That was the reason. Maybe you could have figured it out, but I don't want to confuse you in your first program. So I said, read it in this order, and I'll explain in class why am I forcing you to read it in this order. Okay? And this will happen in every language, believe me. I've seen it in C, I've seen it in C#, I've seen it in old languages also. Okay? So that was the reason. Got it? So you've been introduced to byte. We haven't seen unsigned with primitive data types, but unsigned is available with classes. There is unsigned. So we'll have to learn, when we come to that, we'll do it. Right now, I'm only talking primitive data. Okay, makes sense? The one part. So I'm going to save this program for you so that you have it as a reference, right? So this is something that is kind of showing you how to ignore extra input. And now I'm going to save this as another one, and I'm going to show you different data types in Java. That was my agenda. So I'm going to save it as kind of odd name, right, of a program. But that's okay. Better than calling it ABC. Okay. So now I'm going to introduce you to primitive data types. Right? So you can kind of leave the things alone. You can remove the extra stuff that is just for you and me. And I called it different data types. I can remove this now. Hopefully by now you know what are the conventions, the begin of class definition. I'm going to I'll need the input for sure. You've seen string, you've seen byte. I'm going to remove the rest. Okay, so you've seen a scanner, which is a class, which is not a primitive data type. You've seen string, which is so common that it is kind of called a primitive data type, but it is not a primitive data type. Now you've seen age, and age is good enough for a byte. Now we have a few others. Let's do ints first. So we have a shot. So how would you declare a shot? You'll say shot. What do you think will work well for a shot? What kind of data is a good example of a short type? And I told you the range. The range is -32768 to 32767. So 30,000 kind of is what we are looking at, the range, and negative and positive both numbers. What would be a good example where you can save a short value, where you will need a short value? Can you think of an example? Come on. 30,000? Students in a college, too much? Students in a university? Could be around that range, right? In our college, we have 6,000 students. So definitely byte will not work, but short will work, right? And it's going to 32,000. So it's good enough. So if you wanted to save or kind of make a box in which you wanted to say how many students in a college, I could use a short box. I could go at int, but the range of int is this. I may be wrong. It's been years since I wrote it, so I could be wrong, okay? I think it is 2147483648. I could be wrong. It's been years since I was a student, but that's the range of an int. Now that's too much for number of students in a college or in a university. So we'll stick to short. So short will do well for number of students in a college. So let's try to kind of work with, let's call it college name or university name or something. Right? Short will do good. Unsigned would be better, but since we cannot do unsigned, number of students would be a good variable to keep the short, right? Byte. Now let's not go age. What do you think would be a good example for a byte? So -127 to 128. Students in a class? Usually it's not more than, our student size is limited to 40, for example. So I should be good with a byte in that case. Why would I go short, right? So here I've said number of students in college. You can kind of make those names as big as you want, or we can call it total students. And here, instead of age, let's go student class size. Make sense? So again, the names of the variables should be good enough, and the type that you are working with should make sense. What about an int? That's the range. Quite a big number. Oops, quite a big number. In terms of a college, I don't know. Where would we kind of think about that number? And that's an int. I'm not talking real numbers. I'm talking int. I don't know. What do you think? Any good example that would work, that you will need as an int? I mean, nothing stops you that total students be that, but I'm just thinking of the right things. Maybe the area of the college? Not a bad idea. Square feet, kind of. I think it's okay. What do you say? You can always Google and see area square foot of Georgian College. I could be wrong, but hypothetically it's not bad, right? So college area or what, or college, I don't want to go dimensions because dimension says length into breadth, so on. So I'll go area covered by the college, right? Not a bad idea. And usually it will not be a floating point number. You don't say 26.23 square feet kind of. You always go complete numbers. Is that okay? And now a long. I have no idea. I have no idea. Long is really a very big number. So I don't know why, like, what we will be a long good variable, at least in terms of college. But if I wanted to see, I don't think they'll tell us. It gives me the address and so on. Square feet? Do you see the answer somewhere, or are you? Yeah, you mean I change my question to something? Yeah. Yeah, maybe it makes more sense. It doesn't understand what it is. Yeah, square feet, Georgian College, something like this. Yeah. 467,000 square feet. Okay, thank you. Does that fact sheet? Okay, there it is. Okay, 467 zeros. 467. Okay, 467. Okay, so that is okay. So we were okay with that. Now a long, maybe area of all campuses. We'll just go that. You know what I mean? I'm just kind of trying to see where things. Though I'm sure it will be still in the same range. The number of campuses could have been a byte. Oh, well, I give up. What do you think? You come up with something, guys. I'm using my brains. You use your brains a little. What do you think? And long is very long, definitely, right? I don't know.
Total students since the college was open?
Total students of what?
Since the college was open?
Not a bad idea.
Yeah, very long.
Yeah, right? Could be. You know what? You could be wrong, right? Because that's 2147 is quite a big number, or maybe
change it to a double and do student debt.
We'll come to float and double in a minute. Yeah, total students till date. We'll kind of go with that. I'm not so sure. We'll come to that. I could be wrong, but we have to look for things that are integers, right? So for byte, I could have said class size, or I could have said number of campuses could also be okay, right? Now, since we are kind of going, if you're going out of Georgian College Berry, we'll change it there. So those are your integer flavors. You have a byte, you have a short, you have an int, and you have a long. Okay, those are your byte flavors. And what kind of value would you like to put in it is I've given you the ranges, right? So you know what the ranges are. And now let's talk about real numbers, what we call real numbers or real types in Java. So there is a float and there is a double. There are two that are available in your Java programming language. Okay, so you have a float type and you have a double type, and their ranges are of course different, and I don't know them by heart because they're big and doubles are really big. So I heard student ed for float. I think float is okay. Let's not go double. That's asking too much. College debt maybe, but yeah, I don't know. We could say college value. College value, like college, how much is the college worth? That would be examples of some examples of float and double. Okay.
We can have the profit earned by the college and not fees.
Exactly. You can say profit earned by the college could become, I would go double. Right? Anyway, so yeah, profit by the college could, I mean, if they see me telling all this nonsense in class, I may be, but you know what? Let's do it. And it's not only fees, there's so many things, you know, it's not only the fees, it's they have the residence and then they rent out rooms in summer for different things. So we'll just say profit earned by college. Revenues, as we say, right? College revenue, as we say. Let's call it college revenue. Again, names are important because they kind of tell you what they are. Okay. Let's look at more now. That's it. That are numbers. So we've taken care of numbers, ints and reals. That's what you heard in math. So I've kind of linked it. Now let's look at the other types. We need text. Unfortunately, there is nothing for text. For string is a class. But there it is, it says class. It's not a primitive data type. But if you wanted to use a single variable, just one character, there is a type called char. What do you think char would work for at the college level? It's just one char. Grade of a student, student grade, A, B, C, D, E, or fail, F. Shouldn't happen in my class, but grade of a student would be a good one, where you can go A, B, C, D, and F for fail. Not a bad one. So let's take student grade. And just so that you know, to initialize a character, you put a single quote here and we'll say every student gets an A. There. Default value to begin with. That's how you can initialize it. But it can need any single character, whether it be a comma, whether it be a semicolon, one character can be saved in that one character type. So there is a chart for your information. Don't use double quotes. Double quotes are only used with string. So that's char. That's another data type that is available in saves a single character only. It comes handy sometimes. And there is another one. You want to work with true and false, off on. Oops, wrong spelling. And it's called Boolean. And it can take two values, true and false. Okay, what do you think, Boolean? I don't know. In terms of a college, Boolean, true, false.
Attendance.
Sorry?
Attendance.
Attendance, yeah. Attendance is compulsory in Georgian college. Yes, no, true, false. Some colleges have attendance to be necessary, or you can say something like athletic center. Does it have an athletic center or not? Maybe all colleges have gyms, but I'm not sure. So I've seen the athletic center come after I've joined the college, so we didn't have an athletic center. So yes, but attendance is necessary, right? So or no? Right, and just for information, you can assign it two values, true and false. It's not a string, okay? So for us, it is false. And that's how you assign. So one is false. A Boolean variable can only take two values. So if you want to keep that here, a Boolean data type can be assigned or take two values. That's all it can be assigned. You can't do anything else with it. You can actually put a number in it. It automatically 0 is false and any non-zero is true, but we'll kind of go the easy way, right? But it is allowed. If I assign it as 0, it means false, and any non-zero number is true. But this looks more nice. So notice false with a small f, t with a small t. That's a Boolean variable. That's it. Those are the basic data types in Java. Yes.
If you don't give a value, is it automatically true? Or
Okay. Good question. Your name?
false? False.
Spell it out.
Thals.
Thals. Thales. Yeah. Okay. Good to know names. When I'm entering marks in my math, the names are so big, and you have a big name, right? Something, 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 4-lettered name. So Thales. Okay. So he says, what if you don't assign it a value? What's going into all these variables by default? And here's a valid question. So I assign it a value. Good. I can ask something from a user. Good. But if I don't assign values to primitive data types, what happens to them? Easiest way is to print out and see. But for your information, numbers are 0, Boolean is false, and character is the null character. The first character in the character set is called the null character. That's what goes. And if you don't know, all you do is a system out of all these variables that will be one by one. System out println, class size, total students, area covered, total students till date, student depth, college revenue, character, and the attendance. That's their default values, right? So take a system out println and spit them out. That will tell you the default values. Good question. Good. I didn't think about it. I mean, of course, I didn't mention it. So all data types, and to prove it, let's try it. Since Thales asked that question, am I saying it right? Thales, that's how I say it. Okay, not bad. You know what? I'll know it now. I'll forget it after the break. So, so it's okay. So let's try to see what happens in a college name. Okay, thank you. I'm going to kind of, my system spelling is wrong. I'll get an error. Let's do a print F. No, I won't do a print F. It will give you your assignment answer. And let's put college name. And you can repeat this as many number of times as you like, but we have a few. So 1, 2, 3, 4, 5, 6, 7, and 8. And I think there are 8. And then what I'll do is I'll kind of take one by one each one of them. So that's class size. I'll replace it here. I know it's kind of odd that I don't have blanks, but I will do it. That's total number of students. You'll say, what if I don't give it a value? That's student area covered. I mean, if I've proved for one, I've proved for the others, but that's okay. Total students till date. And why do I give headings? Because otherwise it makes no sense. I won't be able to see what value is coming into. Oops, Control Z, Control C, Control V, oh, Control V. Okay, college revenue. And I'll not assign it, okay? This was just to show you that how you assign it. And the null character is an unprintable character. You won't be able to see it. My mistake. And again, I won't do the attendance so that you can see what the. And of course, if I was really writing a good one, I wouldn't use names like this. I would go something like this. I would say college name. Then I would say, because that's the whole purpose, right? I would say class size. I would say total students in the college. I would say area covered. I would say total students till date. I'll kind of make it neat because then I'll say student debt. Average student debt. We'll say average student debt because every student will have a different one. You know what I mean? Like, and I'll change the name here also because it's always a good idea to give names that make sense. So let's say average. On an average, what's the student debt of a student at Georgian College? And that's the college revenue. Notice how what you print should be this. These are called literals, okay? Whatever in double quotes is a literal. And I'm not changing my variables. Oops, student grade is kind of odd, but anyway, there it is. And attendance required. Again, you can change the name here. You can say attendance required or compulsory, and you can do it here. And notice for all my identifiers, I've used the camel case naming convention. So I forget whether in assignment 1 I said anything about it, but hopefully I can remember in my assignment 2 that you have to follow naming conventions. I think I did, and I haven't put it in my rubric. I better do that. Anyway, there it is. So let's see what's printed out, and that will answer Thail's question, hopefully, right? Okay, so I have a college name here, which is a object, and an object is a little different from a normal variable. Let's try this, okay? And go back, and what was it called now? It's called different data types. Okay, so compile your program. We'll do a CLS to make it pretty. Didn't work. CLS. There. Let's do a JAVAC. And you know what? Shouldn't be that lazy. There. Let's see. Oh God. What is it saying? Ah, okay, because I'm missing my semicolons everywhere. That's what it is saying. There. Copy paste, don't do it right. That's what happens with let's try it again. I still have 8 errors. What is it saying? Let's look at what the 8 errors are. System out println college name. Variable college name might not have been initialized. Oh, it says that I am not going to give you any default values on my own. So it only works in classes, but I'm inside main. It should work. So main is not doing it, but by default, I'll prove it to you when I write classes that they have a default value. And take my word for it. It's 0, false, and whatever. Maybe it's no, it's giving me everywhere. So it's not taking any default values, which is good that you asked the question, I said it, and I've proved myself wrong, but I will prove it to you when the time comes, okay? When you write classes, it does work. It will work. And just because it's not working right now, I'm going to comment it out. It's not working in an application. When you start writing classes, I'll prove it to you that it works. So by default, there are no default values. When you're writing an application in the main method, there are not. When you start writing classes, they all have a default value. By default, they have some value, and I'll let you know what those values are when the time comes. So all that system out println of no use, but that's okay. Now, how do you read it? Let's quickly do it. For the college name, next line, input.next line. For class size, the method is called next byte. For short, next short. For int, next int. For long, next long. For float, next float. For double, next double. For character, next char. And for boolean, next boolean. Nothing difficult to remember, right? Because they're all called next something. And where do I go and look for help if I forget? Scanner class. So open up your API, go to the scanner class, look at the methods, make an educated guess, and oh, will this work for me? Will this work for me? So that all of them can be read, right? So these are your data types that are available. These are your primitive data types that are available, right? Unfortunately, they are only They do not have an unsigned with them. So I look into it if there is a get around with it, but their get around is they gave you classes, right? So Java introduced classes. Annotation is not working, so I'll look it up. I'll have to Google it. I'll have to see about it, how it works. Okay. But those are your basic data types. Do they have default values in an application? We just found out no. We just found out no, it doesn't. But if you read values and you assign values, so you could read them or you could assign them. So you could take college name, though it's, this hard-coded data is a big no-no. Because it kind of says, oh, there is nothing else can I do with it. I can only assign college name what I want. You can do it this way. But as I said, it's a big no-no. Because what does it do? It kind of restricts you to just a calculator that can work with two numbers, kind of. Think about it that way. If you had a calculator, you go and buy a calculator, and it can only add two numbers. It's a useless calculator. So when you work with variables, the best way to work with variables is that you ask the value of the user and put a value into it, change it again, put a value into it, change it again, and so on. Yeah, Boolean variables, sometimes true, false is not a big deal. You don't ask the user. You assign it a value, true and false, and let it go. But in all other cases, the best way to work with variables is to ask the user and make your program interactive. But if you wanted to, a hard-coded data would look like this. So I could take a college name, I could take college size, and I can assign them whatever values I like as long as I know what I'm doing. So college size was a byte. So I'm going to say something like, I think even gen ed classes. What about your gen ed classes? How big are they? I don't know. I've never. Are they big classes? More than 40 for sure. Maybe 100 something. We'll go 100. That you could assign values to them one by one. Total students in the college. Maybe in all campuses. You can go a bigger size. So our range is 3 to 767. So maybe 30,000. You can do this. And then you can print them out and it will print it for you. So you can work this way, right? But that's not how I would say. Therefore, I've said hard-coded data, big no-no. If it is required, it's something else. It is, if you want constants and you don't want their values to change in your code, then it's something else. But otherwise, variables is what they are. Listen, now what's a constant? A constant is a special kind of a box, memory box, that you put a value into once and then you cannot change it while the program is executing. You'll say, will I ever require it? Why not? Suppose you want to put the value pi, the mathematical value pi. It never changes. It's been there forever. 3.14. You don't want to use that magic number 3.14 in your code everywhere. Make it a constant and put it there. You'll say, can I declare constants in Java? I'll tell you how to from my experience. I may again be wrong, but you know what? Trying is how you know. I just finished teaching Python a couple of weeks back. So what I'm trying to do is I'm using my Python here and therefore I go wrong sometimes. But that doesn't mean I don't know Java, guys. I know Java, okay? So don't be afraid. You are fine with me. So constants are those special memory boxes whose value cannot be changed during the execution of a program. Where would you use constant boxes? Where you expect them to be used. You say, oh, number of campuses of Georgian College. I don't know, I think we have 7 right now. So 7, and I don't want to kind of use it as a variable because it doesn't make sense. It doesn't make sense asking the user how many, because I know that there are 7. Or how many buildings at the Berry campus. Right now we can go A, B, C, I think there are 8 or 9. So if you want to have something as a constant value and you don't want to change it during the execution of the code while the code is executed, you can declare them to be a constant. Let's see how you declare constants. God be with me, right? Okay. Okay, so let's try. And any type. Let's start with the reserved word no, final. Saved. They're called final, cannot be changed. So if you put final in front of a variable like, let's call number of campuses. And you can assign it right here if you want, where you have, or in a different line, it really doesn't matter. And I'll say 7. Oh, and what is it, the type? A byte will do. It's such a small value, a byte will do. Now, you'll say, Is there a naming convention for constants in Java? There is actually. I mean, you could use camel case. There is no problem with it. But usually languages so that they stand out. So that they stand out. They're all in caps separated by an underscore. Naming convention for constants. We call them constants. Did you mean naming convention constants Java? Okay. So I know. What is the naming convention in Java? Geeks for Geeks is a good site. So if they have some constant, if they have some, oh, there it is. There is a final notice, all in caps, separated by an underscore. Do you see that? Positive infinity, negative infinity, and so on. That's a constant. Why? Because there is a final in front of it. Ignore the static. Static has nothing to do with a constant. So that's the naming convention of naming a constant. You'll say, what's the big deal? Guys, the big deal is that it's easier for programmers to talk to each other. Anywhere you see something like campuses, campuses, anytime you see such a bit like written all in caps, you can kind of say, oh, that's a constant. And I'll show you, you cannot change a constant. So during the run of the code, this value of, and it's defined, you can print it out. It's a constant, you can print it out. Let's try to print it out, number of campuses. See how lazy I am? I don't even want to type this in. How lazy can one get? I can do this. It's a constant. And of course, to make it better, I have a feeling my spelling of campuses is wrong. Yeah, see, it is wrong. There. The gut feeling was not right. There it is. There. Let's see. What does it give me? Don't forget your semicolon there. Right? So number of campuses should show me the value of 6. And then I'll show you something else. Why is it a constant? So I removed my default statements. I've kind of put them again. What did I do?
Because the number of campuses, their name is different. You guys change the spelling.
Campus. I haven't changed it here. Thank you. Good to have eyes on my work. Come on, where are you? Clear the screen. Let's clear the screen once more. And let's try the JAVAC different data types. What now? College name. God, please help me. I'm losing my semicolons. Python doesn't need semicolons, just for information. That's where it is coming from. Okay, let's run it. Okay, can't do much about it. Don't have it. Tab, remove the class out of it. So the only output that I'm expecting is number of campuses. There it is. Number of campuses is 6. Right? So what's the big deal in it? You took a variable, you put 6 into it, and you're showing it to us. But what I want to point out is this. Now, if to this variable number of campuses, I try to assign a value, or reassign, I must say. And doesn't really matter. In the same code, right? And let's go back and try to compile it again. There. You notice the error? It says cannot assign a value to a final variable. That's what a constant is. You cannot read a value. It's assigned a value once, and that's it. Job done. Use of named constants. 1. Readability. Makes sense, right? Oh, they should be constants. 2. Flexibility. Campuses are 6 today, change to 8 tomorrow. I just go into my code. I go to that one line where I had that says 6 and change it to 8. Everything in the program automatically, wherever I'm using number of campuses, automatically changes to 8. And readability in another way. I'm not going to use the magic number 6 in code anyway. There are 6 campuses of Georgian College. No, I don't want to do that. Why? Because it's a constant. Why will I use the magic number 6? That makes no sense. If I need a number and I want to use it over and over again and I know it will not change, make it a named constant. So it improves readability, flexibility in the sense you can change it and you can change it whenever you want in different runs, not in the same run, but in the same run you cannot change it. Right. You'll say, can I read a value into a constant? You said it can be assigned a value, so this cannot be done. So that's a no. What I did here was I assigned it a value here. Let's try this. Can I say, just for the heck of it, can I say, I already have a scanner. I already have a scanner. The scanner was called input. It's a byte. So yes, let's use next byte. It's no sense. There is a cursor on the screen and doesn't say anything. So let's go system.out.printf. No, I'll stick with print. And let's ask the question. Enter number of Georgian College campuses. I usually kind of make it not a question, but a statement, because after the question mark, it looks odd if, then the print looks odd. Okay, let's see if this can be done. We already have the input scanner. I've used next byte to read a byte. And can I do this? Instead of assigning it a value, I know it's a constant, but can I read a value into it and keep it? Or will I have to assign it a value, hard-coded value right in the code? Let's try this. So this is a no. So I have kind of commented it, right? But let's see, can I do this? Can I do input into my number of campuses? Okay, let's go back. Let's compile your code again. And it compiles. Okay, let's run it. It says enter a number of campus colleges. I'm going to say 7. That's fine. Once I can either assign or read it. Now let's try this, the one that I had commented out. Can I read it again? Or can I give it a different value? Let's compile it again. Okay, here. I see the error. I can do this. I can do it again. So whether you read it or whether you assign it, depends on you. If you say, oh, I know its value and it doesn't change, you can do it this way. So declare constants, assign or input only once. So either way, but then you cannot change it. And then you cannot change it. So that's what a constant is. They're called final variables in Java. One side I'm saying final and then I'm calling it a variable. So that's what they're called. In other languages, they may be called, you could, instead of the word final, you could have const, C-O-N-S, for example. So if you're reading code, constants and finals are same. Java just chose to call it final. I don't know why. I'll have to ask Gaussian about it. Then, seen different data types, know about different methods, right? Done. Any questions on this? Are we okay? So next float, next double, next byte, next char. Character can only have a character, a single character in single quotes. Try double quotes, you'll get an error. It has to be put in single quotes. Okay? We are all okay with basic data types. Of this, you will use float in your code and you'll do a printf. Now let's do a little bit of math. Now let's try to do something that we have started writing code. So here I've introduced you because it was the easiest way. The default value question was asked. I thought it would do it because in classes it does. It gave me runtime errors. I gave up on it. But now once you have it, you have the college name, you have the class size, and you have total students. Of course, after that, you can do it. After that, you can, of course, print it out. Nothing stops you. It's just like any other code that you've written. Oh. There. After you assigned a value, you can do it. So hard-coded data, no. It's a big no-no because the whole purpose is lost then. As I said, think of it as if there's, or think of your iPhone which can only dial one number. Kind of stupid, right? Or YouTube, you can only listen to one song. Anything that's kind of cannot be, it's not repetitive, doesn't do different jobs. It's a useless kind of device. So definitely when you use variables, if you're working, maybe you're working the same application, somebody has written this application, will work at Georgian College, will work at Durham College, will work at all colleges all over Ontario. So then it becomes more useful. Okay, but yes, if you were writing an application for Georgian College only, then you could hard code data as required. So I could say number of campuses is a constant. I could say college name is a constant. At least those two I can make them as constant. So that's how you think. Okay, let's go to the next step now. Oops, I'll take a break. Right time for break. Take a 20-minute break, and then we'll do some arithmetic and Java. Okay, so I'll put this on Blackboard for you so that you can see it. So today we've already done two programs, one a small one, this one again is just what it is. So if I go to your agenda, and this is, I don't know how many of you have looked at it, but for example, in Monday section programs, I'll start using GitHub, but I don't want to kind of overwhelm you with things that are not even there. So week 3, so that's, let's say, week 4 item. So this is how it will come, okay? I'll kind of put it in week 4. And that's the date today for you, though it really doesn't matter. And I'm going to browse my computer and give you what we did today. So under the Monday section, under week 3, we've already done student information and we've done different data types. And we'll do something else and then I'll put it back. So the two programs that I just did in class are already up on Blackboard. Okay. Take a break here, have your lunch, come back in 20 minutes. Oh, people are loving me. I have so many emails. Yes.
For some reason, it's not giving me the class.
What?
Data types. So like when it tries to load the class.
You mean you can do it on your command line is what you're trying to tell me?
Yeah.
What does it say? Just go tab, press the tab key. Start with the D now. So this is the running. So have you compiled it? Do you know you've compiled it?
Yeah.
Do not find out. Maybe, but I see it in your. I see it in your. I do see it in your. Are you in the right directory?
Yeah.
Okay. Let's go to the end and say .java. Maybe it has compilation errors. Yeah, that's the problem. It has compilation errors. Okay, so open your code. And it says semi. Oh, the next line is missing opening and closing brackets. No, opening and closing also. So it's not complete. So next line, opening and closing brackets. It's a method, right? And then a semicolon for everyone.
Today, I'll go today, but I did bring my shorts if you want. What shorts? Okay, so I'll just be at home, but just give me something when you're free, and I'll just go and take the bus or something. I do have phones, but it's just weird, so I'm not really doing much. So I'm just gonna see that. I'm doing that right. Gave back. Yeah, you have to put the just on track. Oh. Yeah.
Okay, guys, let's do a little bit of arithmetic now, right? So again, I'm going to change it and call it something like arithmetic or play with math or something, and then kind of change stuff. So let's call it I'll do, if I get time, I'll do operations also. Let's call it, let's start with arithmetic, then I'll change it. There. Oops. Okay, so I'm going to write a new code. It's just easy because then I don't have to write all my comments. Don't you do it, okay? You write everything from scratch. And I'm going to save it as there. And now let's introduce you to the various arithmetic operators. And maybe, you know, go a step ahead. If time permits, I'll do some methods also with you. So we can kind of, we'll need the scanner. I mean, we can do it without the scanner also, but it's a better, okay, here. So there you go, right? So create a skeleton, write your name. If you love my name, copy my name, write the date and the purpose of the code. And then if we need any packages to be imported, which definitely will always need the scanner if you are going to read, take input from the user, call your class, use the Pascal naming convention, try to give it a name which makes sense. I've called it arithmetic operations. Should have a main method whose signatures are public static void main string arguments or ARGS. And then now you can kind of a little, you know, you can, since now you are writing your fourth program, you can say declare an of the scanner class. And I mean, you can just say declare and create an object to read input. Have some water, it should go. That's what my parents used to tell me. I'm not sure. There. Okay, so we've created an input. You can call it whatever you like. Again, I've told you that the word input is not compulsory. It just kind of makes sense to call it input, but you can call it anything you like. Okay. Now let's do some arithmetic. Now you have to be very careful that arithmetic in Java, better stand near my podium, that the arithmetic in Java is different for integers and it is different for floating point numbers or real numbers. We call them floating point numbers in Java. I'll stick to real numbers if it makes more sense. In terms of, especially in terms of division, right? Addition is okay. You add two integers, you get an integer. You multiply two integers, you get an integer. You subtract two integers, you get an integer. But when you divide two integers, you will always get an integer. On the other hand, when you divide two float numbers or add or subtract or multiply them, you will always get a floating number. So integer division is something that you have to be careful about in Java. So 3 divided by 2 is not a 1.5 in a Java program. It is only a 1. It will remove the 0.5. So integer by integer always gives you an integer. So let's try to write a small calculator here. Okay. Now, the second thing that you have to remember in division is division by 0 gives you an error, a runtime error when you're trying to divide 5 by 0. So integer by a 0. On the other hand, God knows, maybe he just loved real numbers, whoever wrote it. In floating point numbers, if you try to divide a 0 and it doesn't blow up, the result comes out to be NaN, standing for not a number. Now, why this step kind of, you know, thing with an integer or a float, I have no clue, but that's how it works. And I'll show it to you. So let's try to create a small calculator today. A very small calculator which can which will take two numbers from the user, can add them, subtract them, multiply them, divide them, and also find the remainder when you do them. And I'll do both for you. I'll do integers for you, and then I'll do it with floating point numbers so that you can see it. Generally, when you write a calculator, what type of numbers will you use? Integers or real numbers? What do you think in a calculator? Real numbers, because calculator works with all kinds of numbers, right? So that would be your general type that you would use. Now, would you use float or double will depend upon, oh, my calculator can only work in this limit, or mine with this big numbers and so on. And even in a normal calculator, there is a limit. Have you ever tried in a calculator giving a very big number? It comes up with error on its screen. It does. So there is a limit. I mean, it's a machine. You can't put things into a box and overfill it and say, oh, it should still work. How can that happen? So irrespective of whatever, there is a limit that you have to say, oh, that's why limit cannot go beyond it. You can go to a better type. For example, the double type, the class double, will take a bigger range from the primitive data type double. But again, there is a limit. You say, so what? Can do infinity kind of numbers? Can, but a little different coding is required. I can start using collections, and there is no size to collection. So I can say, oh, give me 2,000 boxes. And then imagine if you have 2,000 boxes and you put a number in each one of them, you're working with very huge, big numbers. So it can be done, but using the normal primitive data types, there is a limit. Using the classes, there is a limit. Okay, there is a big decimal also for information. There is a big int. So there are big classes, but again, they all have limits. Now, if you wanted to see, oh, what are the floating point numbers? What is the limit of a floating point? If I was writing a calculator for floating numbers and you want to see the limit of float numbers, and it's quite big, but I mean, when we say quite big, we could be just saying, oh, that's not what I need. So I'm trying to look for, oh, there it is. There's a docs here. Will they kind of show me? That's not what I'm interested in, but it may show you. So here, just for your information, the float, the maximum value, and their constants, they've been defined. The maximum value that you can hold in a float is 2 to the power, oh God, that's quite a bit of a number, but that's the maximum limit you can store. Here, there's a constant, the minimum that you can store is 2 to the power of minus 126. So they're not small numbers, or they're not large. I mean, they could be fine, but these values they have defined these constants for you. You can find out what is the maximum value of a float and print it out. You can find out what is the minimum value of a float and print it out. You can see what the negative infinity will give you, or what will positive infinity give you. And it's just system out println. So if I wanted to see what is the maximum value of a float variable, I just have to use this class called float and use this constant called min value and max value. And I can tell you what is the minimum value of this float and what is the maximum value of this float class. But if you wanted to look for the float normal variable, float data type, it's the float primitive data type, or you can just say data type also. And it will tell you, this is what I can go for. And I can't remember it because it's not easy. Like, it's not as if I would know it by heart. So see, these are easy ones. Byte 128 to 127, minus 3 to 768, and so on. There it is, floating point number. Does it say something in terms of its range? It would be nice if they could tell me the range and I could show it to you to kind of make you say, oh, that's what their default value. No, that's the default values. See, here it says it's not always necessary to assign a value to answer Thales' question when a field is declared. But they're talking about fields, and fields are related to classes. And that's what I was saying. All numbers are 0. Floats are also 0, except it's a 0.0. This is the null character. Any object null, and Boolean is false. So here they are, but only in a class. Though they say that they should work. Strange. It is saying it in the manual and it's not working. Maybe it just doesn't work in. I can't find the value. I don't know. Oh, see, talking about hex value and bin values. Remember the other day I was mentioning that you can work with octal numbers and binary numbers in Java. Notice how a dec val has been defined given a value 26. a hex val should start with a 0x. That's what it says, it is a hex constant. And a bin value must start with a 0. So you can use hex variables and binary integers in your code. Here is a double value, which is not a big value, but whatever it is. Here is a double value written in exponent form. E to the power of 2 means 10 to the power of 2. You can even enter your hex double numbers and floating point numbers like this. And a float number, though this is odd, but I'll introduce you to today, that you have to put an F when you assign a value to a floating point number. Otherwise, it assumes it is double. Okay, but I was showing you the range, and I can see it anywhere. It would be nice if they could just tell me, oh, the minimum value is this and the maximum value is this. It says the float data type is a single precision 32-bit this. Its range of values is beyond the scope of this discussion. Come on. Anyway, but it is a huge value. Okay, let's start working with it. Open your code. So as we thought, we will use floating point number. So I'm going to declare a variable called float and call it number1. If that's okay, you can call it whatever you like. First number, number 1 with an ONE, number 1 with a 1, but it just means that it is my first number. And though it is not usually the practice in Java, every declaration is done on a different line, but you can declare more than one variables on the same line. So both floating number 1 and number 2 are both floating numbers. You can declare more than one variables on a single line. Nothing stops you. The result can also be declared here. But the convention usually in Java is, in Java programming language, one variable per line is how it goes. Okay, that is the convention. And we will follow it when we start writing classes. But this is logically, syntactically, there is nothing wrong with it. Okay, and just for the, just so that I can show you what happens with integers, I'll show you with hard coded. Okay, my aim is to basically show you arithmetic operators in Java. And there are plus, minus, multiplication, division, and the modulus operator, which is actually called the remainder of dividing two numbers. So for example, if I divide 7 by 3, the remainder is 3 2s are 6 and the remainder is 1. If I divide 9 by 3, the remainder is 0. Right? This is called the modulus operator. And this is its symbol, the percentage sign. That's what the modulus operator is. What remains after dividing. Okay. So I'll introduce you to that too. And now another one that you've done in math, the exponentiation to the power of. Now, as per se, Java does not have an exponentiation operator. But there is a math class that has a method called exponentiation, by the help of which you can take any base, any power, and say what is the result of this to the power of this. But there is no operator as per se. Many languages may have it. Java just chose not to have it. Okay. So now let's build a small calculator today for you. So let's build a small calculator. A simple one. Let's see how it works. Okay. So if you're going to work with a calculator, you better have your two numbers asked from the user. Otherwise, it's a useless calculator. Okay. So let's ask the two numbers. How would you ask? You would give a message on the screen. Please input the first number. Please input the second number. You will read the numbers using next float, put it in two boxes called number 1 and number 2, and then you will work with them, right? Logically. So in terms of pseudo steps, what should be your steps? Your steps should be ask for the first number, ask for the second number, right? And then add the two numbers, subtract the two numbers, divide the two numbers, multiply the two numbers, and find the remainder, or use the modulus operator. You can draw it in a flowchart if you want. How many of you have seen flowcharts in your lives? It's not so tough, but here is how flowcharts are drawn, and you should be aware, you should be able to read it. Flowcharts use symbols like this. Start, right? And pseudocode uses points, okay? So I would write start here. So input my first number. You can, if you're printing something on the screen, then you use these symbols. These are called input-output symbols, kind of a rhombus. They are called input and output symbol, right? So you will say input number 1, or input first number, or accept first number, whatever you like. Here you would write it in English, input first number. What would be your next step? Your next step again would be input second number. And I'm not doing any kind of error checking or anything here. I'm assuming you all are very good students and users. If I ask you for a number, you will give me a number. You won't say anything else. Here it would be written as input second number. So this is called pseudocode. And if you have difficulty in kind of putting your thoughts down in a program straight away, write a pseudocode first and then translate into Java. It will help you. Okay. And now, what is your job? Your next job is I've taken my two numbers and now I want to maybe add them. Computation is shown in square boxes. Right? Computation is shown in square boxes. So you can write it in English, or flowchart is a little more mathematical. I can say sum result. I've called my variable sum result is equal to, here you can say input first number and call it number 1. Or call it first number 1. You can start giving them names, though their names are not given. It's just said, it's written more in English, add the two numbers. Number 1 plus number 2. And after that, you can do all your computations, goes difference and so on and so forth. And then you will display them again using your, this is output. Output the sum, output the difference, output the product, output the quotient, output the remainder, and stop. Right? So flow charting and pseudocode are two other ways of coding, but they are not something that the computer understands. When you really have to code, you have to use a computer language and then compile it and run it. But as first year students, you should know that what is pseudocode? Pseudocode. Code that looks like code but is pseudo, like false code. And it's just English like, as if you would put the steps in 1 to 10. And what is a flow? I read my first number, I read my second number. I add them and print the result. I subtract them and I print the result, and so on and so forth. Now, would you draw flowcharts by hand? You could if you like, but of course there are programs that are available. If you Google it, you will find some programs. Or also, I used to draw them using the Visio in the Microsoft suite. They have a program called Microsoft Visio, and you can draw flowcharts there. Very easy to make. The only things you have to remember is ovals for start and stop, rhombus or whatever you would like to call it, quadrilateral or whatever for input and output, and square or rectangles for computation. And if it is a big flow chart and you have to go from page to page, then you kind of draw a connector at the end here, a connector like you say 1 here at the end, and then you start from 1 again on the next page. So these are called connectors. Suppose your page finishes and you still have to draw more, these are called connectors, right? So open up Microsoft Office if you have it, open up Visio, and you will see that these symbols are already present. So you have computational symbols, you have input-output symbols, you have start and stop, which are terminals, and then you have the connector. When you do more, I'll tell you about more symbols. When you do the decision-making and iterative, then I'll tell you about those symbols. So you should know how to write pseudocode and flowcharts, right? So pick up a few examples and read about them. Okay, let's ask the two numbers of the user. So how do you ask? You give a message on the screen. If you don't give a message on the screen, it's really useless because nothing is on the screen. The only thing that is happening is the cursor blinking, and you're saying, what? Like, what do I do? So ask the question. Please input normal English grammatically correct question. Please input the first number. And again, it's a good idea before you do anything. It's always a good idea to say what the program does, to introduce the arithmetic operators in Java and build a simple calculator. And before you start asking the user of the two numbers, it is always a good idea to display what does the program do. And you can kind of write anything that kind of makes a little sense to you. Oops, except that use the right there. You can say simple calculator, like the heading. You can kind of describe what a simple calculator is. God knows. jumping from place to place here. And you could even kind of give, we'll ask for 2 numbers from the user, and like you can add a few things. We're kind of just, you know, just telling what the program does. And it's a good idea because if I don't know what's happening, it's kind of difficult to work with it. And we'll kind of, again, how much will you need, how many will look pretty, and so on. You can kind of decide afterwards. So I can take the system out println and copy it in every space, and that way I know, oh, I need this much space. Try to make them even, right? Semicolon missing, semicolon missing. The user will be asked to enter 2 numbers. And you can say the sum, difference, product, and quotient remainder will be displayed. So there, I need more place. So as soon as you kind of go here, you kind of go here, try to make it the same size. That's how it will look neat. The whole idea is to make it look neat. So the sum, difference, product, quotient, and remainder will be displayed. There. We need a couple of more here. We need a couple of more here. And I think we are okay here. And we need a few more here. When this comes on the screen, it tells me exactly what your code is doing, which is a good way of starting a program. Okay, so now let's take the input and please input the first number. We'll kind of keep it here because we said it's a good idea that you can ask it. You don't have to use print. You can use println if you want, but again, if you're asking a question, the user, and you expect the user to enter it in front of the question, use print. If you're using println, the question or the cursor will blink on the next line. So that's your first number taken. That's your second number taken. So you can copy and paste, but please remember to change the message. Now, when you're asking a question, you are expecting to take input, and we will keep our first number. We will scan it. And what have we declared them as? Float. So what method am I going to use? Next float. There. So input, scanner object, please help me read a floating point number from the user. Put it in number 1. A question is asked again. Now we will see if enter works and everything is okay and we don't have to put an empty one. Please ask the second question. And don't put it in the same box. Put it in a different box. Input is complete. Right? So these are called prompt messages. And I've said, please write clear, complete, and grammatically correct messages. If you are asking me a question and you're just looking at me, I have no clue what you're asking. So therefore, we say prompt messages must be complete and clear. And similarly, the output must be clear in the sense, I say the sum is 12. Sum of what? 6 and 6? 10 and 2? 8 and 4? 12 can be sum of many numbers, 24 and minus 12. So when you show your output, see that your output is complete. The sum of, show the value of number 1 and show the value of number 2 is show the value of result, right? So see that things are complete and clear. I don't have to rely on you to say, Brett, can you please tell me what does your output mean? No, I don't want to. I don't want to email him. I don't want to email 120 students saying, what does your output mean? Okay, and that's exactly what is the same thing with me. If I'm teaching you, I should be clear, complete, and give you all information correctly as best as I know. Okay. Okay, so my input is complete. That's all I have to ask. Now, what is your next step? Now, your next step is computations. Or you can, if you want to put it in more simpler words, calculate the sum, difference, product, quotient, and the remainder. Which means there are two things. You may just calculate them on the fly and show the result. So here is the sum, here is whatever, and you don't save it anywhere. One way of doing is like that. Just calculate it on the fly and print it out, print the answer on the fly. You don't save your answers anywhere. Good enough, can be done for something like this. Who wants to save it? But remember how in your calculators there is also a button called memory and you can save it. So similarly here, if you want to save your answers, create boxes for it. If you just want to create them on the fly, just show the answer and then it's gone. You don't have to do anything with it. Don't create any boxes for it. Entirely depends upon the application you are writing. Sometimes you may say it's of no use, but what will I do? I use a calculator, I give it to you. Are you interested in my answers? No, the calculator kind of cleans it and says, here, you have an output and I'll show it to you. So that's fine too. So you could do your calculations in the print statement itself, or you could do your calculations, put it in a box and show the value of the box. Both possibilities are available. You'll say, is one better than the other? For kind of, quick, dirty, small programs on the fly. If you're going to learn work like a programmer, always keep your results in boxes if you need them further in your program, right? So both of them can be done. Okay, so if I need boxes to keep my result, instead of just one result, maybe I can do something like this. I can call it sum if I like, right? If sum is not a reserved word, I can call it difference if I like. I can call it product if I like. I can call it quotient. I call it remainder. Yes, so I've declared some more float variables now. Now I will do it and then I'll tell you something. It may happen that when you add up two floating point numbers, you get a bigger answer and you need a double for it. When you multiply two floating point numbers, you get a bigger answer and it cannot go into a float box, you need a double for it. So for product and for sum, you could use the double types, assuming what if the user gives the maximum float value. You can, like suppose suppose assuming I can only put maximum I have a box in which I can put 0 to 9 maximum. And then I put 9 in the box and I put 9 in the box. 9 and 9 is 18. Can I put it in the same box of the same size? No, I need a bigger box, right? So when calculators are written, they don't assume that you're adding to a float, you will always get a float. You will get a double. With subtraction, there is no problem because you're removing something. So if you're working with two floating numbers and you're removing something, your answer will always be big. If you're multiplying two things, your answer can be big. If you're adding two things, your answer can be big. And division, your quotient will always be small. Quotient never goes big. So maybe for sum and product, you can make those double. Or you will say, you know what, I'm too lazy to think about it. I'll make all my result variables double. But again, I say, think like a programmer. So if you think that the sum and product logically can be bigger, make them double, the rest can work as simple. Why? Because subtracting two numbers will always give you a smaller number. Dividing two numbers will always give you a smaller quotient. The remainder of dividing a number by another number will always be smaller. But adding two numbers or multiplying two numbers and they're already at their maximum limit, it can give you a bigger number. So you may use them as double to be there. That's one way. So instead of saying, oh, my results will be floats, you can do this. You can take all your results if you like, and this will depend upon your application. It's not your personal preference here. You're writing an application for a client. The client exactly tells you, these are my requirements. You logically think about it and you decide which box do I need to work with. Okay, so it's not as if, oh, Anju said so. No, it's you think about it. So according to me, I don't need the difference and quotient and remainder to be doubles. They should work with floats. They can, logically. Have you ever seen the two numbers, the difference of two numbers is bigger than the two numbers? No. Same with quotients, same with remainder. Sum, yes, I can understand. Product, I can understand. And so can you hopefully, mathematically. But if you like, you can take all your results variable to be doubles. Okay, now, just so that you know about it, because you may not even ever see it, you could initialize your numbers to something, default something if you like. You can always, or on separate lines also, like here. Though I've said it's always a no, I want to show you something. And I want to show you that it's an error. If you wanted to initialize number 1 to 3.5, which is a float, and number 2 to 6.85 or whatever, which is a float, I'll get an error here. If you assign a real number to a float variable, the requirement is that you put an F at the end of it. Otherwise, by default, 3.5, the literal 3.5 is a double value. Right? So you say, do I take a word for it? No, don't take my word for it. Let's save it and compile it, and you will know the error. It will give you an error right here. So let's compile it. So this is called arithmetic operations. Okay, so let's go back. Let's clear the screen. Let's do a JAVAC. And hopefully, if I haven't started anything with A, there it is. Let's compile it. Oops, I get an error. You'll say, I don't see any error. I've said it is a float. I'm giving it a real value. Why is it marking on me? Like, it's fine. The rule is that if you assign, not when you input it, I'm saying assign. If you assign a value to a float variable, you have to put the letter F after its literal value. It's a requirement in Java. Because by default, otherwise, any real number in Java, any literal in Java is assumed to be a double. Okay, so if I was doing it, which we won't, we are asking the numbers. If I was doing it, what will I do? I'll just put the letter F after it, and I won't get the error. Right? And you can make a note for yourself if you like. So by default, when I say by default, I mean automatically. By default, real literals. What is a literal? Something that you can, what it is, what is you see. What you see is what it is. So 3.5. Like the example is 3.5. I've taken 6.85 are assumed to be double values. Therefore, so use F if you are assigning it to a float variable. That's for your information. You may find it handy. Sometimes you may have to declare a float constant and you want to give it a value 3.14 pi, and it won't work. You'll say, what did I do wrong? I said final float pi is equal to 3.14. What is happening? You forgot your F after it. Same thing will hold for constant. So if you were declaring a constant, you have to put an F after it. Okay, that's a rule you have to remember. So by default, real numbers or real literals or real values or real numbers, whatever you would like to call it, start using jargon that is more compute like, more programming like. They're called literals. Okay, and they're called float literals or real numbers like this, like the ones I've used, are assumed to be double. So use F with it if you're assigning it to a float variable. And just on the same note, if I had an integer, by default, it is an integer. Any number, any 2, 3, 6, they're all integers. If I want to convert it into a long, I'll have to put L at the end of it. Just on the same note, okay? So if you see L somewhere, it says, oh, otherwise, all numbers are assumed to be int. A whole number is assumed to be int. You can give it to a byte and so on, that's all fine. But for a long, you will have to put L with it when you assign. So this don't forget, because this is a very common mistake. Okay, so this is just to show you. Okay, and now when I compile it, I shouldn't be getting any compilation errors. Okay, I've put an F after it. So now this is very odd. You never do it in math. You don't write an F with a real point number. That would not be a number at all. It is a 3.5 F. But in programming, in Java, you have to put an F if you want to do a hard-coded assignment, which we've already said, no. Okay, so the two numbers are ready. Now what? Now let's calculate the sum. The variable is called sum. Sum is assigned the value number 1 plus number 2. That's it. That's your arithmetic operator plus. Assignment happens at the last. BEDMAS rule is followed as in math. There is no BEDMAS here, there is only a plus. But BEDMAS is followed in Java also. The assignment operator happens at the end. The right-hand side is evaluated first. Assignment happens at the end. This is the assignment operator, okay? This is kind of right to left. So the right expression is done. The result is assigned to the on the left. The difference. For now, I'm just saying take the number 1 and subtract the number 2. When I tell you the if statement, we'll talk about it. The product. Take the number 1 and multiply by number 2. So you're seeing arithmetic operator, guys, okay? And the quotient, now you may not call it quotient if you like, but I can think of a better word in mathematics. Please change your operators. That's the multiplication operator. That's the division operator. And you can make a note of yourself. Integer divided by an integer is equal to integer FYI. Don't forget that. I'll show the result to you. 3 divided by 2 is a 1. It's not a 1.5. And lastly, let's check. Can we use the remainder operator? Guys, your break went too long, isn't it? Did you sleep somewhere? Here. There. It's your class. You can come and go whenever you like. But I don't want you to lose anything that I teach. It's so important. Anyway, so there they are, the 4 operations. The sum, the difference, the product, the quotient, the remainder. You could have called them result 1, result 2, result 3, result 4, result 5. Which names are better? These ones are better. It's like student 1, student 2, student 3, student 4, student 5. How stupid is that, right? So always give good names. What convention am I following? Camel case. I started with a small letter. I don't have double words. You could have called it sum result, difference result, quotient result, product result. But these are good enough. So don't go overboard. But don't forget the conventions and the use of naming variables. Computations done. You've seen the 5 arithmetic operators? Yes. Now we want to print our results. So when I say comment your code well, including your name, date, and purpose at the head, it has marks. If I don't see this, you will lose marks. If I don't see this, you will lose marks. If I don't see things like what you are doing, you will lose marks. I'm not telling you to write essays. I'm telling you to write comments. Here it's okay. I can see that what a plus, what a minus, what a multiplication and division means at least, but I've said calculate the sum, difference, product, quotient, and the remainder. Right? It makes sense. So I'm not looking for essays, but I'm definitely looking for comments. And they will have marks. And if you've not seen the rubric, you may not have, because I've just attached it today morning. You will see that there are 4 marks for commenting in your code. And there are marks which I think I forgot to put, but I will immediately, as soon as I finish class, I will, for naming conventions. If I've asked them in my assignment that follow naming conventions, then there will be marks for naming conventions. Okay, so if the assignment says, then there will be marks. Okay, now my next, display the results. That's my next. So it's always a good idea to put some white space characters in your code, easy to read. Okay, now what? We want to show and we want to print out our results, right? So the program had a heading, told you what to do. Then the 2 questions were asked. And now I want to do some pretty printing again. And just because I don't want to give you the solution for your first assignment, I will not show you, I will not use printf. I will use normal concatenation operator. I hate it, but I have to wait till you give in the assignment. After Thursday, next week onwards, I'll start using printf. And once you've seen it, then I can use it. Okay, so now I want to show you my two numbers. So here, here, you can kind of replace it with output, or you can say arithmetic output, or you can say arithmetic results, whatever. So you can go something like this. Okay, just makes it look pretty, nothing else. There's no big deal in it at all. Okay, what would you like to show? Do you only want to show your sum, whatever? No, you want to show the numbers also. Don't expect me to remember the numbers I input. I'm an old one. I forget what I input. The screen has cleared. I have no clue what did I do. I can't remember 1 minute to another minute. How can I remember the numbers I do? Very foolish, but yeah, that's what it is. Okay, so you will always show the input the user gave in your output if it makes sense, right? So now if you simply say the sum is 12, and I forget what the two numbers were, then I say, oh, did I give 6 and 6? Did I give a 8 plus 8 and 4? Did I give a 10 and 2? Did I give a 12 and minus? I don't remember. So when I say the output must be clear, complete, that means I want to see everything. Kind of think that the previous, whatever was on the screen is gone, and now all I can see is the output. You can give me complete messages. The sum of this and this is this. The difference of this and this is this. Or you can say something like this, because we are kind of showing it together. Though the calculator never shows it together. You can do all 4 operations together and they come on the screen. You only do one operation at a time, right? But here, I'm kind of trying to show you all results together. So let me show you the first number. And look at my headings. The headings must be human readable. I'm going to show you my first number, which I called number 1. I'm not using printf I'm not using printf for a reason. Because I cannot give the result out, the assignment, what I've asked you to do in the assignment. And again, it's a good idea. You've done percentage S. You could use percentage S and give all of them the same size. Or here you can kind of go this way and at least start them from the same colon if you like, because it's not so big. You can do it this way. It will be neater, but formatting is the way to go. You don't want to keep playing with it. If you need 20 dashes, you should just say, oh, print this 20 times. Or if you want to say first number, leave some blanks, start the colon at the same position, you should give each of these strings the same size, right? And then it will look much prettier. But printf, I'm keeping away from it. So copying and pasting will do wonders, as long as I know what I'm doing. Okay, so I want to show the sum here. So I'll kind of have to go tab. I'll use the tab because that way it is easy. Then I don't have to count. So I'm going tab and I'm going tab. And then I'm leaving a space and then I'm going, the answer is shown in sum. If you wanted, you could have done the mathematical operation right here itself. And I'll do it for you just to show it to you. I could have without the boxes. So I'll write it here so that you can see it. You could have done it right here. Here, you could have done it right here. But because you've used a plus, you could have to put this here. Okay, so I can do it on the go. Like I can do the addition right here and show it on the screen, and then it's gone. It's nowhere. It's not saved. Should be okay for such a silly program, but may not be okay if you're writing applications and you need your answers over and over again in further computations. But here you could do it. It's no big deal, right? My second one is the difference. And since I've used a tab, it's easy. It would be much more easy if I knew how to do printf. I've just forgotten it for today. I'll recollect it. I'll learn about it. Next week, promise, we'll start using printf. Why didn't that tab work properly? It's okay. Remember, this plus is not the plus. This is the concatenation operator. Don't forget. I'm missing my semicolons again. Now, a normal human being, when I say normal, I mean a non-mathematical. I don't mean normal otherwise. Wouldn't know what a quotient is. I mean, if you say quotient, he or she may not understand what a quotient is. But we are arithmetic people, okay? We learn math together and we do Java together. So we are good. Or if you don't like to write words like this, you could write the thing. You can write the value number 1 plus number 2 is equal to number 1 minus. You can write the whole equation yourself, like an equation. So if the two numbers were 3.5 and 4.5, you can write the equations. Like you can show your answers like this. There is nothing wrong in it. 2.5 plus 3.75 is equal to whatever. You can write your answers like this. There definitely it would be nice to use format specifiers, but there's nothing wrong. So instead of saying sum here, I'll give you another example. I could have even done it like this. It's a little more work, but again, how you show your output is entirely up to you, as long as it is complete and clear and everything. I could do it like this. I could have said number 1, show the value of number 1. Then I would have said the concatenation operator. Then I would have used the plus inside it. And then I would have said number 2. And then I would have said plus, and then would have said equal to, and then would have said this, and then I would have said this. Here, let's see this way also. For sum, let's see always. Right? So there are, so don't worry, sum is coming thrice. Okay, just to show you the different ways in which you can show your answer. So you can write it in like a whole complete sentence also if you want it, like this. If I'm at it, I better do it. Yes, you could have done it like this also. Right? So it would say the sum of number 1 and number 2 is this. You could, I've already written the first two numbers, so it doesn't make sense of repeating it. I could only say it like this. I may not even put it in a box. I may say it like this. Or you can write it in equation form. Choose one consistent way of showing your output. I'm showing it to you in different ways doesn't mean you'll do the same to me when I ask you in an assignment. So how your output is shown should be consistent, whatever you like. It should be complete, clear, grammatically correct, and correct, of course. The answer should be correct. But use one consistent way of showing. See, everything is consistent, should be consistent. I should be able to recognize you by your output. So this is, this is how he writes. It's your writing style. It's your coding style. It's your output style. Everybody is different. Softwares are different, right? How TextPad looks is different from how Notepad looks. The NetBeans IDE is different from Idea IDE, IDE, Ideas IDE, right? Just because of how they look. So you can make your own styles. I'm just giving you different ways of doing it, but don't do it 4 times. And then comes the remainder. And let's see what happens in the remainder with floating point numbers. And at the end of the day, maybe you just want to use printf and write it in another way. And that's perfectly fine too. Here, let's see how the results look. Right? So looks okay, but when you compile it, you may have compilation errors. I just saw I had spelling mistakes and so on, and which is okay. It will happen. You're doing it for the first time and you're just trying things out, and it's okay. And I make so many mistakes. You yourself see, oh, I forget my semicolons and I do stuff like that. Which, what was it called? Where? In the remainder line. When I'm calculating the remainder. There you go. Thank you. There, right? So syntax errors are small things that will come with time, and that's okay. That's no big deal. Logically, you should be strong. You should not have logical errors. That's more important. Syntax you will learn with time. Otherwise, the compiler will tell you, oh, I forgot this, I forgot that. But logically, you cannot go wrong, right? Okay, let's save it. It was called arithmetic something. I think we've already done something with the arithmetic. Let's clear the screen. Let's try to do a JVAC with arithmetic operations and see how many errors have I made. I have 3 errors. I said something, something, something. Bracket is missing, it says, in one place. Oh, I see a plus missing for sure. Copy and paste. What else? Okay. So I see my errors. So the sum of, there is a plus here, there is a plus here, there is a plus here. Where was I missing? It said Java 51. You can always go to line 51. You know that. Go to line 51. Join line search. Sometimes you can't see it, so you have to open your eyes. So there is the plus that is missing. Oops. Oops. Anything else? It said 51 only, right? All 3 were at 51. Okay, because it got confused utterly by I missed a plus, which is okay. So 1, a plus, a plus, a plus, and a plus. Again, white space characters only for human eyes. Okay, let's try it again. Still, difference, variable number 2, spelling is wrong in difference. NUMMBBER, there you are. How quickly I have to clear my screen. I make so many mistakes, right? Okay, there. Not a bad thing. I mean, there were not any logical errors. Who knows, I must have made logical errors. Let's see now the results of it. So let's run it. Seems like I don't have Java. Okay. If you don't have Java, you better write it. Okay, here. So it starts. It says, simple calculator. The user will be asked to enter 2 numbers. The sum, difference, product, quotient, and remainder will be displayed. Neat enough? Makes sense? Tells me what your program is doing. Otherwise, I have no clue. I know something will happen, but I have no clue. Now I know what the program is doing. So it says, please input the first number. When it says number, I'm assuming it can be positive or negative, integer or real. If you have to be specific, then you should say, please enter a positive whole number. Then I know, oh, you're asking for a positive whole number. If you're saying please enter a number, I'm assuming it can be positive or negative, reals or integers. So your messages are important. Your prompts are important. So since we are okay, we'll kind of go 3.5 and we'll keep it simple. We'll go to 4.5. My math is not too good, but here it is. So your first number is 3.5. Your second number is 4.5. The sum of 3.5 and 4.5 is 8.0. The result is still showing a 0.0. Though it's an 8, but because my value was a double type, it will still show a decimal point. Then the sum 8.2 and the sum 8.0 are coming from the 2 other print statements, and the equation is also coming from the equation type. So these 4, I've written them in 4 different ways just to show it to you. Okay. The difference is minus 1.0, which looks okay. 3.5 minus 4.5. The product 3.5 into 4.5, I'm not so good, but I'm assuming it is right. It's 15.75. And now look at the quotient. It's 0.07777 and it gave up some time. It's a double value. I think it gives 16 or could be 12. I forget. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 places after decimal is the default for a double value. That's the default. You didn't tell it. You didn't say how many I want to see. It says here, see everything. So the default is 16 digits after the decimal point. This is called its precision. We'll talk about precision in the math class. You can always curtail it. You can always round it. You are doing it in your assignment 1, so I won't do it. And then lastly, I am getting a remainder of 3.5. Does that make sense to you? When you divide 3.5 by 4.5, I cannot divide it. So the remainder is 3.5. Try dividing 3.5 by 4.5. It's like dividing 2 by 3 or 3 by 4. Can you divide 3 by 4? No, it's 0. 4 times 0 is 0. So the remainder is 3. And it's giving you the remainder. Everything works. Good to know. Let's try it again. Let's give the second number as a 0. Division by 0. You see something? It says infinity. Ah, that's what we heard in math also. You said something divided by 0 is infinity. I don't know why mathematicians did that. They should have just said undefined. So Java will say infinity. I don't agree with whoever did that, but I can do nothing about it. And NaN is not a number. It's a short form of not a number. So it says you're trying to divide 4 by 0. You can't, I mean, what are you expecting? I can't divide by 0. So how can I give you a remainder? So it's not a number. You'll say, oh, I'm happy with it. It makes sense to me. I'm sure you're happy with it because you do it in math. But let me tell you where you will not be happy with it. So looks okay? Yep. Can I work with negative numbers? Sure you can. Nobody stops you. Can I work with integers? Of course you can. Because an integer is a number. It's a float number. But notice something. The results are all real. Because your inputs are real. You say, no, I gave a 3 and a 4. But where did you save them? In which boxes? Float boxes. So though your input was a 3 and a 4, they went into boxes as 3.0 and 4.0. Or minus 3.0 and 4.0. So the results are all positive, are all real numbers. Now, let me show you something you may not like. If you're happy with infinity, I'm just not happy with infinity. I would have been. But think of a common person. You'll say, who? A common person doesn't use a calculator. I would disagree with that. Go to grocery stores and they can't add 4 plus 3. They can't do 50% of something. Ridiculous. They don't have calculators. They can't do it. They can only scan an item and tell you exactly what it is. If you try to say, oh, something is not wrong, something is wrong. Oh, I don't know. Anyway, so those persons don't know their math too well, but let's try to do this. I'm going to divide 3 by 0. So I'm writing it for you, right? That's one thing I'm doing. So 3 divided by 0 was an infinity there. Remember? In the floating point number. And I'm going to do the same thing. I'm going to use the modulus operator. That's your remainders operator. It's also called modulus operator, just in case so that you know. It's called the modulus operator. Okay? The percentage is called the modulus operator. I don't want to see a blank face. And where does modulus operator sit in bed mass? With the D and the M. Siblings. D, M, and modulus operator are siblings. Because it's not in bed mass. There is modulus. It has the same priority as division and multiplication left to it. Okay? So that you know, because we haven't seen it in math. Now let's see what happens here. We have to compile it again. We got 239, no big deal. There we are. And there we are. It will still work the first one. And now see what I get. So it gave me everything was fine for real numbers. Why? Why do they get a special attention? But look at what I get with when I try to do the division by 0. It says I get a runtime error. It's a runtime error. I'm getting an exception. It says, and you can make head or tail out of it. It's not that tough. It says you have in the thread name. You say which thread? Java programs, every running process is called a thread. Okay, it's called a thread. You can run multi-threads at a time. So it's called a thread. What is the name of your thread? Main. What is the exception you get? Arithmetic exception is the name of a class. It's an exception. It belongs to the java.lang package, java.lang.arithmetic exception. So it's an exception class. Somebody's already written it for you. And the error message is division by 0. Why this different attitude with integers? If they wanted to do it, they better do it with both of them. Why didn't you write an infinity? And that's why I don't agree. Like, either behave the same way. Division by 0 is division by 0. Doesn't matter what numbers you're dividing, or just don't do it, or do it. Preferably, I would say that it should have said, on a computer or on a simple calculator, see what it says. Let's see what it says. But it behaves the same way in both cases, hopefully. Okay, so I'm going to do a 3.5 divided by 0. It says cannot be divided by 0. Makes sense? Floating point numbers. Okay, let me try to do a 3 divided by 0. Oops, clear. And I can still say 3.5 divided by 0.0 just to kind of say they're floating point numbers, but it still says the same thing. Let me clear it. And let me try 3 divided by 0. At least it's consistent. At least it's telling me I cannot divide by 0, right? But I don't know why. And believe me, it wasn't that when Java started. Java 0.1, Java 0.2. I'm not sure. Did it come in 3 or 5? And they must have had a reason for it. I've never even gone and read the reason because I don't like it, right? But in the beginning, Java and Chem, it always had that exception. Whether you were using floating numbers or whether you were using. And then they changed their mind out of the blue. I have no clue why. Right? So you will see an infinity. Now, what about modulus? We couldn't see the modulus result because the program stopped right here. Runtime errors, program stops abnormally. Let's try to see what happens here. The other one was able to give you a NaN, not a number. Let's see what happens here. I'm not expecting it to behave any differently. This is my first number. This is my second number. I again get an arithmetic expression division by 0. Now I'm trying to do a modulus operator here. Oh, you know what? No, I could be wrong, but no, I don't think so. But I'll try it this way. It really doesn't matter, but still giving me an error. I commented this line out of the division. I'm doing a modulus now. Maybe it got confused between the plus and though it doesn't. The concatenation is a concatenation. I'll have to compile it again. And I'll have to run it again. Input the first number, input the second number. It still says the same error, though the error is not correct even. It's not division by 0. I mean, in a way, it is trying to divide by 0, so it cannot handle the remainder, but it's giving you an error. It's not saying NaN, not an error. So go and read about it if you like. I don't so I have, but you do now. Okay? So that's how arithmetic operators are. Okay, now it's all in one page, one line. It's a small program, doesn't take a lot to do. So it's fine, it's no big deal. But you know what? It would be nice if I could delegate the responsibilities in a program to different methods. So I say, student 1, your job is this. Your job is this. Your job is this. And then I become the master. And I say, you do your job. Now you do your job. It's your turn next. It's your turn next, and so on. So we will learn how to do methods next time. But I said I would introduce you to something small. So I'm going to do this just for the heck of it, because we don't want to see so many ways of writing our answers. I'm going to comment this out. I'm going to comment this out. I'm going to comment this out. And I'm going to do something a little different for you. What if you always wanted to subtract the smaller number from the bigger number? Here it is only doing number 1 minus number 2. I have 10 more minutes, guys. I'm not taking the time. Right? What if I want to subtract the smaller number from the bigger number? Here I don't care. I just say number 1 minus number 2. But if you could make a decision, if number 1 is smaller, then subtract number 1 from number 2. But if number 2 is smaller, subtract number 2 from number 2. What are you doing? You're making a decision. Right? And this decision is called an if statement in Java. In any programming language, it's called a decision making statement. Exactly like R. If it is raining, carry an umbrella. If I'm bored to death, leave the class. Right? So let's write a small if. And what I'm going to do in this small if is I'm exactly going to write it here, where you did your difference. Let's write it here. I'm going to find the positive difference. Which means what? I will always subtract the smaller number from the larger number. I have to make a decision who's big and who's small. I don't know. So let's make a decision. How do I make a decision? So what will you use? Use a decision making statement in Java. And how do you say it? Exactly like you said. If my number 1 is greater than, or it can be equal to, doesn't matter. Equality is okay. Equality, the answer will always be 0, right? So if my number 1 is greater than or equal to number 2, where am I writing? Here. I said I was somewhere, I was typing. Does that look okay? So what have I used? It's called a relational operator. The symbol that you are using here is called a relational operator. And since begin, if is it can have more than one statement, so you may be doing more than one job. If it is raining outside, wear a raincoat, carry an umbrella, because maybe you're just too sensitive. You want to be well prepared. Wear your rain boots. So you may be doing a number of jobs depending upon a condition. So when you are doing you want to do a few things, put them in begin and end. If you only want to do a thing, you don't need the opening and the closing brackets. But just putting opening and closing brackets will always be good. Then if you have to add something afterwards, you don't have to worry about it, right? So to find the positive difference, subtract the smaller number from the larger number, use a decision-making statement and the relational operator. So if there is one relational operator, there are definitely more relational operators. I am hoping that you can make educated guesses. There is a relational operator called equal to. 2 equals make an equal operator. There is a relational operator not equal to. There is a relational operator greater than. Relationship between 2 numbers or strings. There is a greater than equal to. There is a less than. There is a less than. Here are the relational operators in Java. So you've learned arithmetic operators today and you've learned relational. So what am I saying? If my first number is greater than the second number, what should your difference will? Number 1 is bigger. Right? That's what I said. Else, what must you do? Else, what must you do? You must do this. There is your first if-else block in Java. Does if always require an else? No. If may have an else, if may not have an else. You would want to do something if a condition is true, but may not need to do anything at all if the condition is false. I wanted to do 1 in each one of them. So if the number 1 is bigger, I'm subtracting number 1 minus number 2. Else, what must I do? I must subtract number 2 minus number 1 because number 2 is now bigger. Else automatically means if I'm saying look at the condition. The condition says, is the number 1 greater than or equal to number 2? Yes, subtract the smaller number from number 1. Else, there is no other option. The only other option is it is less. So do the opposite. Why should you write the condition again? Don't write the condition again, because if you write the condition again, you are making extra work to be done by the circuitry. So don't say else and don't put your condition again here. Don't put the condition again. And some students will. I don't know why. Some students will do it. And I'm going to put it on a different line so that I can show you that it is not required. And they'll do this. But I would say don't use it. It's redundant. It's useless and time consuming. So I'll kind of take this back here just so that you can, I mean, this is just a personal preference. Do you want to put your opening brackets on the same line or different lines is your personal preference. I'm trying to use something that is common in the programming world on the same line, but that condition is redundant. Don't put it. It's automatically true. You know what I mean? If the first number is not greater than equal to, definitely it is less than. Why would I write it again? You will say, but what's the problem? The problem is extra code, extra mistakes, and extra work by the circuitry, right? So we'll stop here because I'm sure you're not ready to wait for me to show you the output, but I still will. So I'm going to compile it once more. I'm going to run it once more. I'm going to give it 3.5 and a 4.5 again. And notice my difference is 1. It's giving me a positive difference. So it did 4.5 minus. It did it for me, what I told you. So you have been introduced to, the exception is because of that table, right? So you've been introduced to the arithmetic operators. You've seen one of the relational operators. The rest are not so difficult. You know what a flow chart is. You know what a pseudocode is. And you've seen the first flavor of the if statement, right? We'll come back and we'll do methods next week. And this is going back on Blackboard.